Hey everyone. I just wanted to share this with you. This might be like a really boring thing, but I had a situation where I had to write Python code that generated G code for my CNC machine. I have a Haas VF2, and there's a part that this is my part, so there's no NDA or anything like that. Basically, it's a very thin-walled part that has tiny teeth around the OD, and there's another part that's similar to it that has teeth around the ID. But for the purposes of this, I'm just going to show you this one. And the problem is that, at first I thought I'd be able to drill. Let me make this bigger. At first I thought I'd be able to drill out these things, but it just didn't work well and it was way too slow. I had to work something out to where I could broach these teeth. And basically, like, the part would be mostly filled in when I broach it, so it's not flimsy, and then I clear out the material at the end. I'm not even sure that this is going to actually physically work, but the point is like I use Python to generate. Well, let me back up. These teeth are going to change a number of times during the prototype testing. The number of teeth, the shape of the teeth, maybe even the material, and there's not a good mechanism to do these type of broaching operations on a vertical mill. Haas recently came out with a CAN cycle that does broaching operations. Maybe that'll be better than what I did. They don't have a visual programming system for it yet. On the mill, they have it for the lathe. The point is that I looked into their CAN cycle for it, and I wasn't quite sure I'd be able to use it to its maximum potential. So I wrote my own Python script that allows me to enter in a bunch of parameters, and then it generates the G code for me. So I'm going to walk through that so you can see kind of how this works. If you don't know Python at all, I'm not going to go through how all the Python works. If someone cares enough, for the 5 people that watch this video, if anyone cares enough to really for me to walk step by step through it, I can do that as like a primer to Python or whatever. But so basically, let me just show you how this works. This is just a folder on my computer. Here's the actual script. If I double click on it, a command line comes up and it asks OD or ID spline. Well, on this part here, it's an OD spline, so OD enter. Enter the number of grooves. Well, for testing purposes, I'm going to do 2 grooves that are 180 degrees apart from each other. This particular script that I wrote in Python always assumes that they're equally spaced. So if you had weird spacings, you'd have to do individual outputs for each of those weird grooves. But this assumes there's always going to be an equal spacing between however many grooves that you have in this spline. So 2. Enter the absolute Z height that is safe for movements above the part. So this is just your safe distance. Where can the tool be and not hit your part if it was moving around in the X and Y? So for me, it's going to be, I'm going to set my 0 right at the top of the part when I do the broaching. So anything above that's fine. I'm going to do 0.1 inches. Then it says enter the feed height. This is the absolute Z height that begins the downward stroke of the broach. So if you're going to, when you start actually plunging, that's the height you start plunging from. So I'm going to make it a little bit closer. So 10 thousandths, 0.01. Enter the bottom height. This is the absolute Z height at the bottom of the broach stroke. So this is kind of self-explanatory. You start at the feed and you end at the bottom. So I'm going to go down a quarter inch, so negative 0.25. Enter the distance from the center of the part to the center line of the broach at its final location and press enter. This is a little tricky. If you look at this here, and I turn on this broach tool, which is my broaching tool, and I look normal to it. So this is its final location here. The distance from the center point where your 0 is, and it has to be in the center, to the center of the tool when it's in its final stroke, not when it's out here moving in, when it's here at its final stroke. That radius is what it's asking for. So for this, let's say it's going to be 1 inch. It asks for the orientation of the first groove in degrees. The first groove being toward the operator, the groove being towards the operator is 0, to the left is 90, at the rear machine 180, etc. So in this image, if your x-axis was this, you're looking directly overhead of a vertical mill, so your x-axis is over here on the right, and your y is at the top, and you're on the z looking downward at the part. This would be 0 at the bottom, 90, 180, 270. So let's say we want to start at 90. So 90 degrees. Enter the step over of the broach. This is the amount of material that is removed each stroke. So if each time you stroke down, you want to shave off 5 thousandths, put 5 thousandths. Enter the number of steps. So this is just if you're taking off 5 thousandths per and you want to do that 3 times, so you're doing 15 thousandths of extra material, then you would say 3 times. So we're going to do 3 strokes per groove. Enter the feed rate of the broach during the cut. This is just the feed rate. So for me, I'm going to do 10 inches per minute. Enter the tool number of your broach. For me, I'm going to use tool number 1. Enter the desired work offset. I'm going to use G54, so 54. Boom, it disappeared. What happened? What happened is in whatever folder your script is in, we'll dump in this output file in G-code. So let's open it up. There it is. This is all the boilerplate code that starts in the beginning. The first groove, downward stroke, downward stroke, downward stroke. The second groove, downward stroke, downward stroke, downward stroke, and then turn everything off and do the cleanup at the end of the file. So I'm going to show you this running. Well, I guess first, let me just show you the actual code itself if you just want to see what it looks like. And if someone really wants me to go through like how to actually do Python coding, that's fine. I can do that. So when you have this on your computer, you can, on a Windows machine, if you have Python installed, by double clicking on it, it'll run it in a command prompt. But if you right click on it and say edit with idle, which is the development environment for Python, it'll open up with idle, and you'll see what that looks like. Here it is. So here's the actual script that produces this. Looks like a lot of gibberish, right? But I'm gonna briefly just walk through this just for a second. So the whole script, the whole file starts down here. This says if name equals main, then run the main function. What that means is when you push up here, run module of a script, whatever file that you're doing that from, which is for me this one, the compiler like assigns it the name main. So if you have 3 different files that are all working together and running at the same time, one of them will be assigned the main one. It's the one that you run the script from originally. So basically, all this is saying is, okay, if I'm running this file, this is just kind of like a convention of Python. You always put this at the bottom so that the script knows to execute if it's being run from itself. If it's not, then don't do anything and wait for someone else to call. It's a little bit confusing. I could get into more detail about it, but basically all it says is when you run the program, it jumps down here and execute the main function. Now, where's the main function? Like, what does main parentheses mean? Well, it's right up here, and it's typical in software engineering to like work up sometimes because you typically have your code running and then it's calling things above it that have already been defined. So I'm running main. Main has been defined up here. So define main. So basically the function main is this stuff underneath it. And so what am I doing? Well, here is I'm asking the OD or ID question. I'm asking the number of groove question. I'm asking the safe height question. I'm asking the feed height question. And I ask all the questions that were in that list. And then if it's red, it's commented out, meaning that I put these little things here that have the computer ignores it. Because this is like for testing purposes, you write stuff in or you write little comments and stuff. And so basically I'm asking all these questions and then I say, if it's an OD, generate an OD file, or else generate an ID file. So I've only written this out for OD right now. I'm going to go back and write ID. But so if it's an OD file, it's going to generate an OD file. This is also, just like main was, a function, and it's passing in all these numbers that were defined up here when I asked these questions into it. So let's find this, generate OD file. So if you go up to generate OD file, here it is defined. Defining the generate OD file, and all these parameters that were passed into it are now accessible to this file. So basically it creates a file by saying file open, and I give it a name, and I say I want to write to the file. That's what the W means. Then file write, this is how you write the G code. You basically create an instance of a file by the open command, and then that file you write to it with this kind of this stuff. So this is just skipping a line. -n means it skips a line downward. So here's the G code that you'd see on any host control. So there's that weird O number that wish wasn't required, and then T, and then tool number gets passed in, M06. So select the broaching tool. This is the boilerplate code that starts any G code file here. This G43 turns on the tool compensation and the length, and then turn the coolant on. And then for every groove, I'm not going to walk through all this math to how I get here, but basically this is just looping through each groove number and writing G code for it in this file, these file write commands. And then for each groove, it's writing step over commands here. And then at the end, it just closes out with all the boilerplate code down here. And that's it. So I'm going to stop it there. That was like a super quick and dirty of how the thing works. But I guess I'm just trying to illustrate that you can use Python to control your CNC machine if you had to. I don't recommend it. If there's a way to do it where you can use Haas's, regular functions and Fusion and or Mastercam or whatever, then you by all means do it. But for this particular project, doing these splines, there wasn't a good solution for it. So I'm going to go to the machine now and just show you that this output file running.
All right, so this is the output from the Python code. So we're going to run it. And that's it. So I used a drill bit just to show, but in real life, I have a tick mark so I can verify that it was pointing the right way. But in real life, this tick mark would be the direction of your actual broaching tool. But basically what it just did is it went on this side, turned the broaching tool inward to an OD groove, went down three times to make the cut, and then came up, rotated around so the grooving tool faced this way, came over here, 1, 2, 3, and then finish the program.